Right, okay. It looks like things are coming up. Okay, good. Right, new link. Let me just pop that in here. Just excuse me for a little second. I forgot that I had a stuck key from yesterday. There we go. Ah, perfect. Right. Stream should be up and running now. All platforms. For some reason, it just didn't want to start the stream today. Not quite sure why. But I think everything is live right now. Should be working. Oh yeah, of course. I forgot to open my terminal today. Let's see. There we go. And let's make a day 4 folder. Oops. There we go. Okay. Yeah. Advent of Code, day 4. Yeah, Advent of Code, day 4. We've done all the previous days so far. They're still on the easy side. I'm still waiting for that sort of brutally hard one out of nowhere to hit. Tends to do that. Let's hope it's not today. There is. I tried looking this up before this year's round, and there was like there is a certain coding style or a certain sort of like programming problem solving style that some of these Advent of Code puzzles use that I'm just not used to. I mean, if you watch the streams, you know that most of my solutions tend to be fairly like procedural. Maybe I throw in a little bit of functional here and there, but there are some like more mathy ones where you just sort of need to figure out the math behind the thing, and those, especially doing them live, I just find very challenging. But let's have a look at this day 4 here today. Day 4, series search. Looks like the chief's not here. Next. So here being the whatever we were, North Pole toboggan rental shop with a broken computer. One of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the Ceres monitoring station. This is also a reference to an Advent of Code. Ceres, of course, a moon of Mars. It's a moon of something. Dwarf planet. Oh yeah, okay. Between the orbits of Mars and Jupiter. Dwarf planet. I think, was this one of the ones that sort of made Pluto kind of like where we realized that, yeah, the debate surrounding Pluto led to calls for definition of planet, and then it got sort of demoted along with Pluto. Well, Sirius didn't get demoted. Sirius was already demoted to Dwarf Planet. And it also features in The Expanse, I believe. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search, your puzzle input. So a word search, typically, yeah, like these, you're supposed to find words in just a jumble of words. She only has to find one word, Christmas or Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, as you don't merely need to find one instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear where irrelevant characters have been replaced with a dot. So you can have Xmas, 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 Christmas, and Christmas this way. The actual word search will be full of letters instead. For example, like this. So finding one here. X. Oh, that was hard. I understand why she wanted our help. Xmas. Backwards. In this word search, Xmas occurs a total of 18 times. Here the same word search again, but with the letters not involved in any Xmas have been replaced with dot. Right. So I did go past a couple before I found this backwards one. Take a look at the little elf's word search. How many times does Xmas appear? Right. So let's start with this one, because we know the answer to this should be 18. Let's just have a look at the input just to get a feeling for the size of this thing. Okay, so it's pretty sizable. I think what we'll try to do, just do it in the simplest way possible. Let's write out, I think my size is a bit big today. Example, just paste in the example here. So I think what we'll do is sort of just the simplest, the easiest sort of way I can think of doing this. Basically just go line by line. When you find an X, you start looking for an M in any adjacent square. If you find an M, you sort of note the direction, and then you go sort of on in that direction. So this, for example, it would find the M, but it won't find the A, so that's not an Xmas. This, it finds the X, it finds this M, but that doesn't have an A. It finds this M, and that finds this A, and that finds this S, which makes this a valid Xmas. So basically just go through, find all the X's, then look for Xmas's in all different directions. I think that is what I'm going to try. So let's just first make a direction, which is in enum. We have left. Oh, we also have diagonals. So let's start with left, then left up, then up, then right up, then right, then actually let's do this in sort of what you call them, like north, north would be up, north, east, east, southeast, south, southwest, west, or would that be northwest, and then all the way back to north. So those are our directions as an enum. And then let's just, since we are going to sort of index this, I guess we just read this thing in as a file. Let our input be read file of example. And to be able to do this by sort of XY coordinates, we want this to be, so at the moment this is just one long string. So just to make it easier on ourselves, we can split this on new lines. For that, we'll need string utils. So if you split that on new lines, then we have sort of something looking like, oops. Oh, of course, example.txt. There we go. Now we have sort of all the lines. If I get this, so we have line by line in this array, meaning that our first index is the Y position and the second one is the X position, which is maybe a bit unfamiliar to most people, but fair enough. So let's just do Y in 0 dot dot input dot length. Actually dot input dot high, and then for X in 0 dot dot input Y dot high. We can then do Y, X, and now we'll print this out just character by character. Yeah, so print this out character by character, MMS, MMS, XX, MMS, XX, MM, yeah. So that works. And then we can check if this is equal to an X, then we know that we start with Christmas. We start with the X here. So then we just do for direction in direction. So this is just all the directions. So north, northeast, east, southeast, so on and so forth. Let's actually just define up here. Just for some ease, let's define the word that we're looking for in a string there, and then just look for the first character of the word. So yeah, for direction in direction, and we don't have a given direction yet. So now we're looking for the M in any of the directions around us. So we can say a case on the direction, and if it's north, then we can do let this character be equal to the output of this case statement. So if it's north, then we want to go input Y minus 1 X. So that is just 1 upwards. And then do northeast. That means going up and to the right. Or I'm not sure. Is my thing split? No. Yeah. So up and to the right. My right is also camera right. Y minus 1, and then X plus 1, so that is going to the right. And then of east, let's do input y, and then x plus 1. Of southeast is y plus 1, x plus 1. And then just south is, of course, just y1, y plus 1. Then southwest is minus 1. Just west is just minus 1 to the x-axis. And northwest, finally, is negative in both directions. Of course, in our case, this will fail because we start at 0, 0, so we start at the topmost character. If that happens to be an x, we will try to look above us and to the left, and sort of if we are, let's say we're at this position. So the character, like, we will try to look northeast, east, southeast, south, and southwest, which is outside the bounds of our sequence. So we need to do a little bit of sanitization. And I guess, so what we can do, this is sort of very easy, very simple. We could do something here and say like, if y equals 0, just continue the loop, otherwise this thing. And that would work, but it wouldn't look very nice. So let's instead create a function, let's call it valid directions, take in x and y coordinates, and return a set of direction. So a set in them is a bit set, basically what you would do in C. So if you have an enum like this, you would say that maybe north is 0, this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, and this is 64. And that would sort of be the bits going up, and you can OR them together, and then you have sort of a bit mask of directions. And that's basically what a set is in Nim. In fact, with the right underlying architecture, you can just cast between the two, which is very nice. So what we'll do here, we'll use the result implicit variable and say that sort of the ones, there are no ones that are always valid. So if x is 0, then we can't return north. Oh, x is 0, then we can't return any of the west ones, so southwest, west, or northwest. And I guess the easiest thing here would be to do sort of like all the directions. Isn't there a... Can I create a set of all of them? We have set utils, don't we? Yeah, nim set utils. And here we should have a full set. Yeah. So the full set of a bool is true and false. This can also be used on enums, I believe. So if we grab set utils as well, we can do directions, the full set of directions, and now we can remove the ones that we don't want, which is easier. Yeah, exclude west. I think we can also use like minus west. What's wrong now? Expression cannot open set utils. Is this so new that we have to do this? I thought that was old. Oh, apparently. Right. So we can't do minus equals on a set. Okay. Yeah. So let's do northwest and southwest. Why does it? Oh, it has no type, so it's inline editing it. That's actually nicer for our case. There we go. So if x is 0, eliminate all of those. If y is 0, then we need to exclude all the east ones. So if we just do this, we'll do a search and replace with west for east. Now we have those. Oh, of course, not east. This would be if x is, yeah, I guess if x is high. So let's define this here so that input is already defined, the global variable. And we can say just input 0 dot high, exclude all of those. Now, similarly for the y direction, we need to do this. And for these, we need to exclude the north, northwest, and northeast. And for this, we need south and southeast, well, southwest. Just for symmetry, let's do this. What are you on about? There we go. And now we can say for there in valid directions for x and y. So now, what are you on about? This is why I don't like having LSP enabled. Case direction, expression case, there of north, has no type or is ambiguous. What are you on about? Invalid indentation on line 37. Seems to be the actual issue because I have an extra bracket there. So yeah, we have here valid directions. Just pick out the directions that aren't valid for the position we're in, and now this code can look nice. So if you do echo C here, and let's just quit 0 after the first iteration of the loop. So since, just to not get a bunch of output. So since we are this M, we should expect to see 2 M's and an S in this case. Which is not what we see. Do I have more than one echo here? I do not. Okay. So let us do a little bit of good old-fashioned echo debugging. I actually saw a very nice idea someone had. There's a package for it somewhere. I think actually it was Treeform. He had a package where you basically, so many people debug like this, like echo out something. And I've done this myself, written libraries. I try to, like, I write echo statements as I go along to like see that everything works. And then I just leave it. I come back after a while and then it just echoes a bunch of random noise and I have no idea what any of it means. because I'm not in that sort of scope anymore. And I think it would be like the thing that he does is that he basically says, okay, record the output of your program as a test, and just use that as a test case. And now you can change stuff, and if it breaks, then you know that something is wrong. Right, so for some reason we are at 4-0, which would indeed be east, southeast, south, southwest, and west, but not any of the north directions. But why do we all of a sudden start at 4? Of course, this if statement right here. So we're of course not. This doesn't start running from here. It's 0, 1, 2, 3, 4. So we're at this x, and we're looking at x, m, x, m, and s, which makes a lot more sense. Okay. So we can see here, of course, we start with an x. So these two are candidates. So if c is equal to our word's first character, so the m, then we know that this is a candidate. And basically what that means is that we now have our direction, and we can go look at characters in that direction. So we should probably sort of take this out into a function. Let's call this peak along the xy direction. Xy are integers, and our direction is a direction, and this returns a tuple xy integers. So let's define that as this case statement, but instead of actually let's call this step. So take a step in this direction. Let's do that. Oh, this is XY, because that's what I'm used to. That's what sort of everyone is used to working with. That made this quite a horrible refactor. Could we do this with a Vim recording? D F this guy. DF that guy again. Insert one of these guys forward to there. Input that and paste. Then go one character back, delete to the end of the line, and append one of these guys. Then go to the line below, go to the start of the line, I guess, and forwards to the lower letter I. Then we can replay that, and it will do this transformation for us. I of course forgot a space, but that's easy enough to fix. So for those of you who don't use Vim, and it appears to have messed that one up, for those of you who don't use Vim, you can basically record keyboard instructions, what you do on the keyboard, and you can replay them, which is pretty nice. Right. So there we have our step function that just gives us a coordinate, and then we can say peak xy int Do we need a peak? I was thinking we could do like peak direction, and that would give us a character, and that would just do let position step x, y direction, and just return through implicit return. Yeah, so I didn't explain that. So here we just have a case statement. We don't have a return anywhere here, but you can see all the cases. So all the cases are covered because this is an enum. We know all the values. If I added a value to here, the compiler would actually complain that not all cases are covered, and it tells you the missing cases. So you need to cover all cases. And since we have covered all cases, and each case is just a tuple, this sort of all just collapses to returning a tuple. And since this is the last statement in the proc will just return whatever this tuple returns, or whatever this case returns, which is pretty nice. Yeah, so pos.y, pos.x. There we go, peaks declared but not used, that's fine. So now we can do this. We can say if we peak from x and y in this direction, do we equal the word? The second character of the word. Then we can echo just x and y. Oh, maybe throw in a little text between them so we can actually see what's going on. If we now print out this, we should just get two m's, two positions, right? And these are the original positions, which is not what we want, which is why I thought maybe we don't need peak. So let us declare this as a variable. Step position is step x, y in this direction. And then we do input y, step position of y, step position dot x. So now we will get step position dot x, step position dot y. It was not happy with that because this is not how you index a double array or a double sequence in them. Easy enough to fix. Yeah, so here you get 5, 1 and 3, 1, which if we look at our input, so we find the first x, then we look for the m. We have two candidates, one at the position 5, 1, one at the position 3, 1. Very nice. So basically what we can do now, we have our direction and we have a step position. So we've stepped one point in that direction. And now we can say for I in word in one.word.high. So go through all the characters in the word. Then look at the step position and is it equal to the nth character in the word? If it is, echo it. And then at the end of this loop, we just say step position, take another step from the step position in the same direction that we were going. And now it will say something like, yeah, so 5, 1. Let's echo out this again. So we get here, it sees 5, 1. Okay. So XM, and then it sees 6.2, this A right here, and then it sees 7.3, which would mean that we have a hit because we found X, M, A, and S. And then it checks the other path, 3.1, but 3.1, why does it print out 1.3? 1.3, so this direction. Why does it suddenly change direction? It shouldn't do that. Did I mess this up? North, northeast, northeast, east, southeast, south, southwest, west, northwest. Yeah, no, those are all good. And it's not that, because that's, you only have this one. That one finds all the way to the end, and then 3.1 is going southwest. 3.1 is going southwest. Let me add a little bit more debugging here. Checking direction. Oops. Right, checking east, didn't find anything going east. Yeah, so it is checking southwest. And it starts at 4.0, so it goes -1, +1. Because that's what southwest means. And then it does this, which is freaking weird. It should have kept going, but in a different direction. Like, it should have gone... Like, why does it stop? It should have gone all the way. Ah, no, it only echoes when it finds the word. So for this direction, we're checking in that direction. We're doing this, taking one step, and then going from one to word high. If the input at step pos y, step pos x is equal to word I, and echo out. Let's just do something like that. Echo that out. No matter whether we found anything or not. Oh, I know what's going on. Yeah, so silly me. It found this, then it goes, oh yeah, I have an M here. And then it checks this, doesn't print anything. And then it goes to 3.1 and finds this S. That's what's going on. Yeah, found S. Okay. So if we don't find anything, break out of this loop. And then just check the next direction. And in here, if I is word.high, found word, I guess. So, yeah. It goes, it finds the X, goes M-A-S, found Christmas. Then it goes southwest, found an M, but it stops at the A now, which is quits out of there. And that is what we are looking for. We are looking for Christmases. Let's just count to 0. In here, we increase our count variable. And let us just remove all of this debugging. Let's remove this quit statement. And at the end, let's just echo out our count. This should now echo out 18. Index defect. That's not what we wanted. Oh, of course. So we step, and then we get to an invalid position, and we try to index our invalid position. I guess we could check, like, is step pos in the valid directions for the position we're in, or we could just check if step pos.x is not in the range 0 to input y dot high, or step pos y is not in the range from 0 to input dot high, break out of the loop. So if we are trying to look at something that's outside of the screen or outside of our sort of play area, break out of the loop. We didn't find anything. Now it should print. God damn it. Index out of bounds, the container is empty. Is this, I think I have an inkling. I can remove this peak. We ended up never using it. Is this the annoying thing where, yeah, the last, so dumb. It splits on new lines, and the last one is a new line, so that will always be empty, which is such an annoyance. So, and it's a let as well. So grab all but the last one. There we go. Now we have 18. Okay, so now we can just grab our input. And I mean, this isn't the fastest thing in the world. Probably we are doing quite a bit of like faffing about. There are probably some easier ways to solve this, but it should be more than fast enough for this. Didn't even have to enable release mode. And that's the right answer. It took me long enough. Yeah, lots of faffing about in today's first part. Let's just hope that part 2 is an easy one, but I do have an inkling that this is one of those just gets brutally hard in the second part, like computationally. The elf looks quizzically at you. Did you misunderstand the assignment? God damn it. Looking for the instructions, you flip over the word search to find that this isn't actually a Xmas puzzle. It's an Xmas puzzle in which you're supposed to find two mass in the shape of an X. One way to achieve that is like this. MAS, MAS. Irrelevant characters have again been replaced with dot in the above diagram. With the X, each mass can be written forwards or backwards. Here's the same example from before, but this time all of the Xmas's have been kept instead. So Xmas's. So here's an A, mass. Oh god, I guess this mass. And then this is one. Mass. And this Yeah, that's the one I just did. Yeah. In this example, an Xmas appears 9 times, not 18 times. Flip the word search from the instructions back over to the word search side and try again. Okay, so this actually shouldn't be that hard. Basically just, instead of finding X's, we need to find A's, and then we need to find that we have an MS in sort of opposite directions, which basically just means checking if one is an M and one is an S. It should be actually probably easier than what we just did. Which is interesting. So let's have a look at part 2. So what do we need? What do we need? We don't need the word anymore. We'll keep this. We'll keep our direction enum, although I'm not sure we'll need it. Well, the valid directions thing is nice. Step. We don't really need, I think. Well, we can use it. Yeah. So go through. We're not looking for word A anymore, or word 0, which was an X. We're looking for an A. And then for direction, basically, let's actually just delete all of this. So now we want to look, so we found an A, we want to look in our directions. So let's grab the valid directions as valid directions for X and Y. So in nim, you can do this. I'm assigning a variable to be the output of a function. They both have the same name, which just means, well, it doesn't mean much. We can do this, but we can also do this, because nim is smart enough to see that one is a function call and the other is, nim is smart enough to see that this is a function call and this is a variable, or using a variable, which is pretty nice. Of course, if valid directions returned a function, this would be different. But this is fine. So we grab all the valid directions. Then we... so we have 2 sets we want to check. We want to check northwest, southeast. So if you create a set out of that, and then do we not have an intersection? I always forget the set logic in nim. So nim has 2 different kinds of sets. You have sets, the ones we've been using, or the sets module, which is hash sets, which is not the thing that we've been using. This is kind of, you hash something and it stores the hashes so you can easily find stuff. That's a different kind of set. What we are looking for is bit sets. Yeah, so it's also described in the nim manual. This is the development version, but it's still fine. It's in here as well. Set type. Don't search. That was annoying. So this is the set type that we're using. We're not using the hash sets. And what we are looking for is the intersection, which is times. So we want the intersection between the 2 directions we're looking for and the valid directions. That will be one of our checks. So let's call it check A. And our check B, check B will be, I guess, southwest and northeast times the valid directions. And then if check A, so if the cardinality, so cardinality is just how many elements the set has. If this has 2, so if both of these are valid for the position we're in, then check that the set of input this is where having that peak function would be nice. I shouldn't have deleted it. I could have copied it over from the other solution. But it's easy enough to type out. Input let's step x, y direction, and then inputs step.y step.x. Again, implicit return. Now we make a set where we peak at from our xy position in check A. Oh, I don't think I can't index a set. Right. Okay, let's do something a bit cheeky here. Create a block. Go through direction in here. And then check the set of characters. Check include peak XY direction. This is very ugly. I don't like that we now have. I mean, this isn't gonna make it prettier, but let's just show sort of how flexible nem can be. For check in this array contains this set and this set. So we want to do, oh wait, what we could actually do, you know what? Okay, this could be cool. If check, and we'll, yeah, we have set utils. Does set utils have, oh, we don't have map for sets. Well, that's a shame. No. I wanted to map the values. Like, my idea was doing something like map it dot peak xy and the oh yeah, I guess we could say to set. This is so ugly. The M and the S. Increase the count. And for this, we also need sec utils. L formed AST. What do you mean? Map edge 2sec 2set. What's? Oh no. Don't do that. Oops. What's the actual error here? Type mismatch. Peak. It. Oh. Just old habit. I put it dot at the start there. There we go. Oh, and of course, this check, we need to check and then do the union or the intersection with our valid directions. No. Oh, and do that on our example input first, just so that we can check our logic. This should, not produce 25. It should have given us 9. So, right. So go through all the coordinates. If this is an A, grab the valid directions from our position. Then for each of our checks, which is northwest, southeast, and southwest and northeast, so the two valid sort of cross positions, check intersect with valid directions should give us that's the intersection. Yeah, so that should give us only values which are in both sets. So as long as both of these are valid, convert those to a sequence, map that sequence, map that. So this is a sequence of two directions, probably northwest, southeast, and southwest, northeast. Then peak in both those directions, which takes a step in that direction, grabs the character at that position, then convert that to the set, the sequence of characters. And if that is M and S, set M and S, increase the count. That should be valid, shouldn't it? Southeast, northwest, northeast, southwest. Yeah, then do valid directions. This should, yeah, just sort of prune off the ones that aren't valid. And then convert that to a sequence. That shouldn't do anything bad. Just stepping through the logic here. And then map that to peak. Oh god, I can't type. X, Y, X. That should give us M's and S's. SS, MS. So 1, 2, 3, 4. And then convert those to sets. So basically remove duplicates and don't care about sort order. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Something weird is going on. I wonder. Just give me the positions that we're checking. Ooh. It did not like that. What the heck? Oh no. Inline errors. Wait, where is there an echo there? That should work, yeah. That's sort of the dark side of using Mac or using. Yeah, so there's a lot of macro magic going on with Mapit and friends. This is sort of what it's actually doing, which will be optimized pretty well, but it looks ugly as hell. So 2, 1, those are both valid. Neither of these are valid. 2 valid, 2 valid, 2 valid. Huh. Okay. Can you give me a look at this? Well, let's have a look at this. So it should find one at 1, 2. Should be the first one it finds. Why on earth do we find one at 7, 0 and then 0, 2 later on? Oh, because we're going... No. What? We're going through in the Y direction, we're going through in the X direction. So we start at the first line and we go through in this direction. Bam. No. Well, we do find this A. So why isn't 0, 1 printed? Or 0, whatever that would be. It was over here somewhere. Go through here, find this. If it's an A, valid directions for each of these 2 checks. Oh wait, we're only looking for the ones where both succeed, right? So both these need to succeed. Still doesn't solve why the printing was weird, but it does solve this. So basically I was adding 1 for this and 1 for this, but this should only count as 1. Why is the printing so weird? Oh, I'm printing XY. Of course, it finds Y0, 7, 7, 0. Is this one, and it finds the S here, but nothing on this end, and an S there, nothing on this end. So it gets 2 S's. And then 2, 1, not 1, 2. So 2, 1. No, 2, 1, which is here. That's in proper Christmas. And it is. And that should count as 1, not 2. Right. So now we should be able to just unleash this on our input. So much for saying that this would be easier. Printing out a bunch of stuff, but yeah. 1835. That's the right answer. You're 1 gold star closer to finding the chief historian. So yeah, that was a lot. Shouldn't have been that hard. Should not have been that hard. Basically, mostly just messing up with X and Y directions. And of course, we have written a bit more code than previous days. But what stumped me ultimately was my poor yeah my poor handling of x and y coordinates. But yeah, so this, not very pretty. Well, it's pretty in its own way. So yeah. It's pretty in its own way. Yeah. We could do this another way as well, which could be fun to showcase. Yeah, so basically we create these sets, which really doesn't have to be sets. Like this could just be a set or a sequence because we convert it to a sequence, like one step further down, because we don't have map it for sequences. Oh no, it can't be because we rely on the intersection with valid directions, which I think is pretty nice. It's a nice way of solving the like this ugliness that sort of creeps into all sort of bound checking code. It's I kind of like this part. Just if it's valid to go in this direction from where we are. Then of course this part is a bit ugly. We need to convert it to a sequence to be able to map it. Would have been nice to have map it on a set. And then we grab characters, and that's turned into a sequence. But then we turn that into a set so that ordering doesn't matter for this equals. Not the prettiest thing in the world. But yeah, it could be cool to have map it for sets. Not sure how useful that would be for anything else than this, but it would be nice to have. Yeah. And then of course this inc valid. I don't really like this. Like we create a variable only to like tick it twice and then check if we ticked it twice. Like this is the magic number. We have used a name, which is annoying. So I want to rewrite this in a kind of an interesting way. So if we create a block here, which is our valid check. Again, we are now using a word, I know. If this check is not equal to what we want, then we break out of our valid check. That means that if we get out of this for loop, then we are then both checks passed. So we loop over the two checks that we want to do. If one of the checks fails, we break out of this valid check block and just continue our looping. If we get through both our checks, then we can increase the count. I kind of like this. No magic numbers. No sort of proxy variable that we edit. And we do need to name a block scope to have something that we can break out of. Because we couldn't just break out of this for loop because that would also drop us here. And we can't continue this for loop because it doesn't have a name. Like we can't continue an outer loop. But by creating a block like this, we can break out to this block. And in my mind, this is kind of cleaner. Like we know that this valid check is doing some work. And we know that if this happens, we are breaking out. We are carrying on after this block. and we increase this count if we get through this check phase. So it's kind of nice. It's I'm not saying it's super pretty, but it does work. And it's yeah, I like it. It's one of the things that you can do in Nim, which you can't necessarily do in all other languages. By the way, I tried to share an article of mine. Is this still not up? So my server had an IP change for some reason. It's never happened before, and I tried to change. Yeah, this is still the old IP. Why hasn't my registrar updated that? Oh, that's annoying. Has it updated any of the other ones? Yeah, so that's updated. So I could go to this page. No. Come on, it's hosted on the same server. Has the IP changed again? God damn it. Yeah. So my server is down. I'm working on it. IP issues. Never happened before. I've had that server for years and years. Never happened. But yeah, so we got to see a lot of implicit returns here. Some nifty set manipulation and breaking out of named blocks. So all in all, a pretty good day for showing off random nim features. So let's go back, have a look at the advent calendar. Ah, yes, this is definitely a Christmas tree, and this is definitely Rudolph, as I figured out yesterday. Still not quite sure what this is supposed to be. This sort of looks like desert with an oasis. Like this is typically water, this blue with a wave. And we have some green around it, which is kind of saying oasis to me. This kind of greenish patch might be a forest or something. But why is this sort of split in two? What is going on there? Are we looking through a window? Like, is this going to be like a window pane thing? It's sort of like offset to the left and it's rounded. This is weird. I'm not sure what we're looking at here, but hopefully we'll find out as Christmas goes on. But yeah, that's everything I had for today. Advent of Code day number 4 in the box. Didn't get a lot harder, but I messed up more. So it took a while longer than it has for the past couple of days. But yeah, that's it for today. Hope you still enjoyed, even though it was a bit long and stumbly. Hope you learned something, and hope you have a nice